Let us now continue our study of organic chemistry. In our last video, we had just discussed how to name alkanes. We now need to kind of discuss some of the different ways to draw out structures so that you are familiar with the terms. Expanded structures and structural formulas are pretty much the same thing. They both show the actual overall structure of everything within the formula. So, for example, if we have butane, the expanded structure and structural formula would look like this, where we drew in all the bonds on the H's, okay, in addition to all of our carbons. If instead we had something like this, and add an extra carbon here, we'd still fill in all of our H's. So these are examples of expanded or structural formulas. We also have something called a condensed formula, which is a condensed version of the expanded formula. Your condensed formula is really kind of like an expanded out chemical formula in a way. So if we focus on butane, which is up here, we have a total of 4 carbons and a total of 10 H's. So the chemical formula would be this, C4H10. The condensed formula kind of separates this out just a little bit. What it does is it kind of indicates how many H's are on each carbon. So if we write the condensed formula for butane, our first carbon here is a CH3. Our second carbon is a CH2. Our third carbon is a CH2. And our last carbon is a CH3. So it shows how many H's are in each carbon. If I write the condensed formula for the other substance I have over here, which is 2-methylbutane, it's going to look a little bit different. I'm still going to start with my first carbon, so CH3. Then I move on to my second carbon. This time this carbon only has one H on it, so I'm going to write just CH. And now I have to take into account this little side chain or branch. I do that by using parentheses. So I'm going to put a CH3 here. And then I move on to CH2. And finally, another CH3. Okay, so that's what a condensed formula looks like. And then aligned structures using lines, we've actually already seen these. You always end up with one less line than the number of carbons. So since butane has 4 carbons, it's going to be 3 lines. And that's because, hopefully you recall, that every end and every bend is a carbon. So we don't show those in the line structure. We don't show the H's in the line structure either. So if I draw the line structure for this one, it's still going to look like that for the main chain, but there's that extra carbon. So I'm going to add a line to represent that CH3 group. Okay. Let's continue on. Thus far, we've learned how to provide nomenclature for carbon side chains or branches. We need to talk about a couple of others as well. So in addition to carbons, such as methyls or ethyls, halogens can also be side chains, like chlorine, so on, fluorine, iodine, etc. All the other rules still apply, so you still indicate the number that this chlorine is on or the number that this fluorine is on. But instead of using chloride, okay, or the YL ending, we use an O. So this is chloro when it's in an organic molecule. This is fluoro, iodo, and bromo. Obviously, halogens are not carbons, and since they're not carbons, they cannot be part of the main chain. Okay, but again, all the naming rules apply from before. So if I had something like this, CCC, and then I have an F off of the second carbon, I would still identify my longest carbon chain, which is propane for 3. And then my F is on the second carbon, so I would name this 2-fluoropropane. So once again, the exact same thing as before. Okay. If instead I had something like this, and I had a chlorine, and I had a chlorine, okay, all my other rules still apply. Since I have 2 Cl groups, it's a dichloro. Okay, so again, it's 2, 3 dichloro, and the longest carbon chain is 4, so it's a butane. Okay. Finally, we need to talk about cycloalkanes. They're cyclic. Okay, that means they are continuous. They're all connected. Okay. The smallest cycloalkane that exists is cyclopropane, which of course will consist of 3 carbons. Okay. And it would look like this if it was in a line formula. Okay. The general formula for all cycloalkanes is this: CnH2n, okay, which would mean if it was a C3, it would be an H6. Okay, and that's because they're all connected, and within our line structure here we have carbons on each end, each corner, and then carbon wants a total of 4 bonds, so there's 2 H's off of each C. Okay. Some additional examples include cyclobutane, cyclopentane, and cyclohexane. Sorry for the drawings, they're not so great. But they're named the same way based on the total number of carbons that they have. And then you just put the word cyclo in front. The next part of the chapter relates to functional groups. Okay. Functional groups account for the smell of compounds. Sometimes things are fishy, sometimes things are putrid or gross, sometimes things are sweet. Okay. That's all based around these additional groups that are part of the molecule. They have different endings on the base names as well compared to alkanes. You do not need to know these for your test. However, doesn't hurt to introduce. So for alcohol, the ending would change to OL instead of ANE. For an ester, the ending would change to O8. For an aldehyde, the ending changes to AL. Okay, there's plenty more. Good news for you, you don't have to know the endings, you just have to be able to identify the different functional groups. There are a total of 12, I believe. So let's go through them. The first functional group is an alkene, which is a double bonded carbon. So if I draw the line structure here, there would be 2 lines. Or if I did this, I would use 2 lines. And I would circle the double bond and label it alkene. An alkyne is very similar. Instead of a double bond, it's a triple bond. So once again, you would circle the triple bond and label it alkyne. Finally, we have things called aromatics, and there are plenty of them. Aromatics have alternating double bonds, but for you guys, it's only going to be a 6-membered ring, and it looks something like this. So it looks like a cyclohexane with double bonds in it. So if you saw this in a structure, you would circle that, the whole ring, and label it aromatic. Let's move on and discuss more functional groups. Here's a list of functional groups that contain a carbonyl group. Your carbonyl group is going to be an O that is double bonded to a C. So you're going to see that these look very similar to one another. And when you see an O double bond C, you're going to want to look at what's connected to it on the left and the right. That will help you figure out which of these it is. So an aldehyde looks like this. O double bonded to the C with an H. So you would circle this and label it aldehyde. A ketone is an O double bond C, and on either side of it are other C's, so you would circle that and say that it was a ketone. A carboxylic acid really doesn't matter how many additional carbons I add to my chain, but a carboxylic acid is the O that's double bonded and then connected to an OH. An ester is going to be a double bonded O to a C connected to just another O. And an amide or an amide is an O double bond C connected to an N. Okay, so your aldehyde group looks like this. Your ketone is just this. Your carboxylic acid is this. Your ester is this. And your amide or your amide is this. Okay, you will definitely want to know these and be able to identify them. Let's do a few more and then we'll do a practice problem. These are the remaining functional groups you're responsible for. They do not have a carbonyl group. So here's an example of an alcohol. Okay, the alcohol is just the OH connected to a regular carbon. Okay, an ether is actually a O in the middle of a chain connected to carbons. An amine is an N, and it can be an N connected to other things. It can be an NH connected to other things, or it can be an NH2. But you'll notice that it's just the nitrogen connected to the carbon, not the double bonded O to the C. And finally, a thiol has a sulfur group. And again, this can be really anywhere within the molecule. But if you see an S, you'll circle the S or the SH and label it as a thiol. Okay, so let's do some practice with this on the next slide. The type of question you would see would be similar to one of these, and the question would ask you to circle the functional groups that you see and identify them. So let's do this first one. Hopefully you see the OH right here. There's multiple OHs. Okay, you would circle that and label it alcohol. You hopefully see the aromatic right here. You would circle it and label it aromatic. Maybe you see the N. You would label that as an amine. Here you see an O double bond C with an N, so it's the amide. Here you see just a double bond, so that's an alkene. And here you see an O double bond C connected to other C's, so that would be a ketone. Okay, this is the type of question you will see related to functional groups on your test. At this time, please pause the video and try to identify the functional groups in the second example. Please check your answers. Hopefully you saw that there was an alcohol, an ether, an aromatic, an amide, as well as an alkene in this example.